Climatic control factors. These are the factors that control climate. And now air masses. An air mass is a large body of air of considerable depth that is relatively homogeneous in terms of temperature and moisture. The general circulation of the atmosphere produces in certain places large masses of air with characteristic and well-defined physical conditions, especially of temperature and humidity. The sources of air masses are the great permanent or semi-permanent high-pressure zones of the Earth's circulation. Conversely, areas of low pressure are regions of convergence. Therefore, the chief seats of major high-pressure cells and therefore the main source of uniform air masses are the polar regions and the cold continental masses of Eurasia and North America in winter. The host latitude high-pressure cells, especially over the oceans in summer, but to a less extent over such large land masses as North Africa and in winter. Now, air masses may therefore be described as polar, tropical, continental, or maritime. The above categorization identifies four individual kinds of air masses, which are tropical maritime, polar maritime, tropical continental, polar continental. Convergence of air masses and fronts. The migration of air masses from their sources must result eventually in their meeting and interference, and this will occur in regions of low pressure, which by their very nature must be regions of convergence. Experience shows that although there is inevitably some marginal mixing and incorporation, the air masses tend to retain their individual characteristics fairly clearly defined, especially in the upper air, which is less disturbed by the turbulence that affects the lower strata in contact with the Earth's surface. The convergence results in the displacement from the surface of the lighter, warmer air by the denser and colder air, and this ascent produces condensation and precipitation. The severity of the disturbance that accompanies this convergence is proportional to the contrast of temperature and humidity of the air masses involved, for the temperature constants provide the main source of energy for the generation of storms. Storminess is great where polar air meets tropical, as it does along the polar fronts, and much less where tropical meets tropical along the equatorial frontal system. The frontal system occur over the world and in all seasons. They are the chief cause of rapid, large-scale changes in weather conditions. When differing air masses meet, a boundary line or front forms. The process is known as frontogenesis. When the front breaks down, the air mixes and the front disappear. This is known as frontalizing. And now the types of front. We have warm fronts, we have cold fronts, we have stationary fronts, we have occluded. And now let's talk about latitude. Latitude influences the global radiation receipts on the Earth's surface. This affects the Earth's temperature distribution. Latitude also influences the pressure pattern, which in turn determines wind flow and precipitation distribution. Within the equatorial zone, that is 10 degrees north and south latitude, the sun throughout the year provides intense insolation, while day and night are of roughly equal duration. Astride, the tropics of Cancer and Capricorn are the north tropical zone and south tropical zone respectively, spanning the latitude belts 10 degrees to 25 degrees north and south respectively. In this zone, the sun is overhead at one solstice, thus mark a seasonal cycle exists, but is combined with the potentially large annual insolation. Altitude. Apart from its effect on temperature, altitude also decrease of temperature with altitude is an average of 6.5 degrees centigrade per kilometer. Altitude also causes changes in pressure and rainfall. Pressure decreases with altitude at the rate of 1 mb per 10 meters. This is up to about 1,500 meters above the sea level, after which the rate is reduced until 4,500 meters above the sea level. When the rate of decrease is only 1 mb per 20 meters, orographic rainfall is brought down as a result of moist, laden winds over mountain beds. Now, land and water masses. And as stated earlier, land surfaces are rapidly and intensely heated under the sun's rays, whereas water surfaces are only slowly and moderately heated. On the other hand, land surfaces cool off more rapidly and reach much lower temperatures than water surfaces when solar radiation is cut off. Relief features. In addition to the effect that mountains have their own climates, they also affect large areas on the leeward side. The ocean basins have a lot of climate influence on their coastal strips than further inland. Not only is the rainfall reduced in the rain shadow inland areas inland, but also temperatures are more